Hello students, a very good morning to you all. I am Shalini, working as chemistry lecturer in Government PU College for Girls, Udupi district. I welcome you for today's chemistry session, and in today's session we have to study about the unit 11 P block elements. So unit 11, the P block elements. So under P block elements, today we have to study the group 14 elements. The group 14 elements. So before dealing with these 14th group elements, so just recall the 13th group elements. So under 13th group elements, we have studied which are the members belongs to this group 13 and what are their general properties, their occurrence and some of the important compounds of boron we have studied under group 13 elements. So today we have to study group 14th elements. And this group 14th elements also we going to call it as carbon family, since carbon is the first member of this group. So here in today's class we going to study which are the members belongs to this group 14, yaudella members ide idralle and their occurrence, their properties, we going to study in today's class. So let us consider one by one. So first one, let us see which are the members belongs to this group 14. So the members of group 14 are, the first member is carbon and its symbol is C. And the second member belongs to this group 14 is silicon and its symbol is Si. And the third member belongs to this group is germanium and its symbol is Ga. And after germanium comes tin. Its symbol is Sn, and the last element belongs to this group is lead. Its symbol is Pb. So carbon, silicon, germanium, tin and lead are the members belongs to this group 14. Now let us consider their occurrence. So ಈ 14th group elements ಎಲ್ಲೆಲ್ಲ ಇರುತ್ತೆ, ಯಾವೆಲ್ಲ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಂಡು ಬರೋಣ. ಈಗ let us consider first element carbon. Carbon is found to be the 17th most abundant element. 17th most abundant element in the earth crust. ಮಕ್ಕಳೇ ನಿಮ್ಗೆ ಗೊತ್ತು, ನಮ್ಮ ಅರ್ತ್ ಕ್ರಸ್ಟ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಇರುವಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವುದು ಕೇಳಿದ್ರೆ ಅದು ಆಕ್ಸಿಜನ್. ಅಂಡ್ ಆಫ್ಟರ್ ಆಕ್ಸಿಜನ್ ನೆಕ್ಸ್ಟ್ ಬರುವಂಥ ಎಲಿಮೆಂಟ್ ಸಿಲಿಕಾನ್. ಹೀಗೆ ನಾವು ಲಿಸ್ಟ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ carbon is found to be the 17th most abundant element in our earth crust. And this carbon occurs in the free form as well as in the combined form. Free form allu irutte athava elemental form anta karitive. For example, ನಾವು coke ಅಥವಾ coal ಅಥವಾ ಗ್ರಾಫೈಟ್ ಎಲ್ಲರಿಗೆ ಫೆಮಿಲಿಯರ್ ಇದೆ, ಬರೀಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಗ್ರಾಫೈಟ್ ಪೆನ್ಸಿಲಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. as well as diamond, it is known to you, it is a precious stone, important jewelry ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲೆಲ್ಲ ನಮ್ಮ ಕಾರ್ಬನ್ ಫ್ರೀ ಫಾರ್ಮಲ್ಲಿ ಅಥವಾ ಎಲಿಮೆಂಟಲ್ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಅದೇ ರೀತಿ ಕಾರ್ಬನ್ reacts with other elements and also occurs in the combined form. For example, ಕಾರ್ಬನ್ ಕೆಲವು ಮೆಟಲ್ ಒಟ್ಟಿಗೆ ಕಂಬೈನ್ ಆಗಿ ಮೆಟಲ್ ಕಾರ್ಬೊನೇಟ್ಸ್ ಆಗಿರ್ಬೋದು. ಮೆಟಲ್ ಕಾರ್ಬೊನೇಟ್ಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸೋಡಿಯಂ ಒಟ್ಟಿಗೆ ಕಂಬೈನ್ ಆಗಿ ಸೋಡಿಯಂ ಕಾರ್ಬೊನೇಟ್ ಫಾರ್ಮಲ್ಲಿ ಬರ್ಬೋದು, ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೊನೇಟ್, ಮೆಗ್ನೀಷಿಯಂ ಕಾರ್ಬೊನೇಟ್, ಹೀಗೆ ನಮ್ಮ ಕಾರ್ಬನ್ ಮೆಟಲ್ ಒಟ್ಟಿಗೆ ಮೆಟಲ್ ಕಾರ್ಬೊನೇಟ್ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಅದೇ ರೀತಿ ಕಾರ್ಬನ್ ಆಲ್ಸೋ ಕಂಬೈನ್ ವಿತ್ ಹೈಡ್ರೋಜನ್ and it occurs in the form of hydrocarbons. The compounds of carbon with hydrogen we going to call it as hydrocarbons anta karitive. So nama carbon hydrocarbon form allu irbodu. Adhe riti our atmosphere contains nearly 0.03% of carbon dioxide gas. ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್ ಆಗಿ ನಮ್ಮ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಲ್ಲೂ ಇದೆ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಡಿಫರೆಂಟ್ ಕಂಬೈನ್ಡ್ ಫಾರ್ಮ್ ಆಫ್ ಕಾರ್ಬನ್. ಈಗ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಸಿಲಿಕಾನ್. ಸೊ ಇಫ್ ವಿ ಕನ್ಸಿಡರ್ ಸಿಲಿಕಾನ್, as I told you in the beginning, it is found to be the second most abundant element. Second most abundant element, and it usually occurs in the form of silica and silicates. Silica andre maralu, SiO2 ಸಿಲಿಕಾ ಫಾರ್ಮಲ್ಲಿ ಇರ್ಬೋದು, ಅಥವಾ ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಒಟ್ಟಿಗೆ ಕಂಬೈನ್ ಆಗಿ ಸಿಲಿಕೇಟ್ ಫಾರ್ಮಲ್ಲೂ ಸಿಲಿಕಾನ್ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಫೌಂಡ್ ಟು ಬಿ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ It is found to be the important component of ceramics. ಸಿರಾಮಿಕ್ಸ್ ಜೇಡಿ ಮಣ್ಣಿನಿಂದ ಮಾಡಿದಂಥ ವಸ್ತುಗಳನ್ನು ಸಿರಾಮಿಕ್ಸ್, ಪಿಂಗಾಣಿ ಪಾತ್ರೆ ಅಂತೆಲ್ಲ ಕರಿತೀವಲ್ವ. ಸೊ ಸಿರಾಮಿಕ್ಸ್ ಐಟಮ್ ಇರ್ಬೋದು, ಗ್ಲಾಸ್ ಇರ್ಬೋದು, ಸಿಮೆಂಟ್ ಇರ್ಬೋದು. ಸೊ ಸಿಲಿಕಾನ್ ಈಸ್ ಫೌಂಡ್ ಟು ಬಿ ಒನ್ ಆಫ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಫ್ ದಿ ಸಿರಾಮಿಕ್ಸ್, ಗ್ಲಾಸ್, cement, etc. In next element tin, if you consider the important ore of tin, we going to call it as cassiterite. Cassiterite ಅಥವಾ tin stone ಅಂತ ಕರಿತೀವಿ. ಇದರ ಫಾರ್ಮುಲಾ SnO2. ಸೊ SnO2 ಆಗಿ ನಮ್ಮ tin ಕಂಬೈನ್ಡ್ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಇನ್ನು ಲಾಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಲೆಡ್ಡಿಗೆ ಬಂದರೆ, ದ ಚೀಫ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಓರ್ ಆಫ್ ಲೆಡ್ ಈಸ್ ಗೆಲೆನಾ. ಗೆಲೆನಾ ಅಂದರೆ ಇಲ್ಲಿ ಲೆಡ್ ಸಲ್ಫೈಡ್ ಫಾರ್ಮಲ್ಲಿ PbS ಆಗಿ ನಮ್ಮ ಅರ್ತ್ ಕ್ರಸ್ಟಲ್ಲಿ ಇದೆ. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ಅಕ್ಕರೆನ್ಸ್ ಆಫ್ ಅವರ್ 14th group elements. ಜನರಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ 14th group elements. So under general property, first property we have to study its electronic configuration. Electronic configuration. ಎಲೆಕ್ಟ್ರಾನಿನ ಸಂರಚನೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಈಗ let us consider first element carbon. Its atomic number is 6, and if you write its electronic configuration, it comes to be 1s2, 2s2 and 2p2, and 1s2 is nothing but the electronic configuration of noble gas helium. ಹಾಗಾಗಿ ನಾನು ಇದನ್ನು ಹೀಲಿಯಂ ಕಾನ್ಫಿಗರೇಷನ್ ಇದೆ, ಹೊರಗಡೆ 2s2 ಮತ್ತು 2p ಆರ್ಬಿಟಲಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಸಿಲಿಕಾನ್ ಬಂದರೆ, ಇಟ್ಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್, ಸಿಲಿಕಾನ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಈಸ್ ಫೌಂಡ್ ಟು ಬಿ 40. ಆ್ಯಂಡ್ ಇಫ್ ಯು ರೈಟ್ ಇಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ಟರ್ ಹೀಲಿಯಂ, ನೆಕ್ಸ್ಟ್ ಬರುವಂಥ ನೋಬಲ್ ಗ್ಯಾಸ್ ಅಂತ ಹೇಳಿದರೆ ನಿಯಾನ್. ಆ್ಯಂಡ್ ಆಫ್ಟರ್ ನಿಯಾನ್ ನೆಕ್ಸ್ಟ್ 3s ಆರ್ಬಿಟಲಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಬರುತ್ತೆ, 3pಯಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಟೋಟಲಿ ನಿಯಾನಲ್ಲಿ 10 ಎಲೆಕ್ಟ್ರಾನ್, 10 plus 2 plus 2, total 14 electrons. So that's why this is the electronic configuration of silicon. And if you consider germanium, so germanium is atomic number 32. Now configuration bardre, we going to get the next noble gas after helium, neon admele next baruvantadu argon. Argon, and next orbital alli 4s orbital contains 2 electrons and 4p level contains once again 2 electrons. But before the fourth shell, inside there are 3d subshell. 4s orbital kinta modlu 3d subshell baratte. First electrons illi enter agate and maximum capacity of d electron is 10 electrons. So totally argon alli 18 electrons plus 10 plus 2 plus 2, total 32 electrons side. Next if you consider tin, so tin atomic number 50, so that's why if you write its electronic configuration, namge after argon we going to get krypton. Krypton admele next illi 2s 2p aitu, 3s 3p aitu, 4s 4p, here 5s 2, 5p 2 baratte. And before the fifth level, ಒಳಗಡೆ 4d orbitals baratte, which can accommodate maximum of 10 electron. So that's why this is the configuration of our tin. In the last element, lead, if you consider, its atomic number is 82. And if you write its electronic configuration, so next noble gas xenon and valency shell 6s2 5s2 5p2 aitu, idu 6s2 6p2 baratte. And before the sixth shell, inside there are 5d orbital which can accommodate maximum of 10 electron. ಮಕ್ಕಳ ನಿಮ್ಗೆ ಗೊತ್ತು ಈ 5d ಕಿಂತ ಮೊದಲು ಫೋರ್ತ್ ಶೆಲ್ ಅಲ್ಲಿ f ಆರ್ಬಿಟಲ್ ಬರುತ್ತೆ. ಸೊ 4f subshell is there and f subshell can accommodate maximum of 14 electrons. So altogether 82 electrons are there. So if we observe their electronic configuration of these 14th group elements, ಈಗ helium ಅಲ್ಲಿ 2s2 2p2 ಇದೆ, 3s2 3p2 in silicon, here 4s2 4p2, and if you continue this one, so the general valency shell electronic configuration of these 14th group elements can be written as ns2 np2. But these elements differ in their inner core configuration. ಒಳಗಡೆ ಶೆಲ್ಲಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಡಿಫರೆನ್ಸ್ ಇದೆ, ಬಟ್ ಇನ್ ದೇರ್ ವೇಲೆನ್ಸಿ ಶೆಲ್ ಆಲ್ ಆಫ್ ದೆಮ್ possess similar electronic configuration, and this one we can represent it as ns2 np2. Now let us consider next general property, second one, that is covalent radius. So covalent radius ಅಥವಾ covalent ತ್ರಿಜ್ಯ ಅಂತ ಕರಿತೀವಿ. As you know, in any group, as we descend down the group, there is a considerable increase in covalent radius because addition of electron take place to the outer valency shell. And same thing we going to observe even in our 14th group elements. As we descend from carbon to silicon, silicon to germanium, germanium to tin, and tin to lead. As we descend down the group, there is a increase in covalent radius we going to observe. But there is a significant increase as we move from carbon to silicon. A large increase we going to observe. But silicon onwards, as we descend down from silicon to germanium, germanium to tin, and tin to lead, there is no such an increase in covalent radius we going to observe. And this is due to the ineffective shielding effect ineffective shielding effect of D and F electrons. ಏನು ಹಾಗಂದ್ರೆ ineffective shielding effect of D and F electrons means, so student, as you know, whenever number of inner electron increases, they will act as shield or they will act as screen. ಅದು ಪರದೆ ಥರ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ಆವಾಗ ನ್ಯೂಕ್ಲಿಯಸ್ನ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಹೊರಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ವೆನ್ಎವರ್ ಸ್ಕ್ರೀನಿಂಗ್ ಇಫೆಕ್ಟ್ ಇನ್ಕ್ರೀಸಸ್, then attractive force of the nucleus towards the outer electron decreases. But the screening effect of various electron belongs to a shell. For if we compare, the screening effect of S electron is always highest because S electrons are closer to the nucleus. Then next screening effect of P electron is less than that of S electron, and D electron comes in next order, and screening effect of F electron is least iratte. So that's why if we consider our 14th group element, most of the electrons are present in D and F orbitals, and their screening effect is less. Ineffective screening anta ಕರಿತೀವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸ್ಕ್ರೀನಿಂಗ್ ಇಫೆಕ್ಟ್ ಕಮ್ಮಿ ಆದ ಹಾಗೆ ನ್ಯೂಕ್ಲಿಯಸ್ನ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಹೊರಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಆಗ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಶ್ರಿಂಕ್ ಆಗುತ್ತೆ, ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಕಾರ್ಬನಿಂದ ಸಿಲಿಕಾನಿಗೆ ಬರುವಾಗ ಎಷ್ಟು ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಆಗುತ್ತೋ ದಟ್ ಮಚ್ ಇನ್ಕ್ರೀಸ್ ವಿ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ಆಸ್ ವಿ ಡಿಸೆಂಡ್ ಡೌನ್ ದ ಗ್ರೂಪ್. ಯಾಕಂತ ಹೇಳಿದರೆ ಅಲ್ಲಿ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆಫ್ ಡಿ ಮತ್ತು ಎಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದು ಕಮ್ಮಿ ಇರುತ್ತೆ. ದಟ್ಸ್ ವೈ ವಿ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ಇನ್ಎಫೆಕ್ಟಿವ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆರ್ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆಫ್ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇನ್ನು ಲೆಟ್ us consider next periodic property, that is the third one, ionization energy. Third periodic property, ionization energy, or in short we going to call it as IE anta ಕರಿತೀವಿ. As you know, if we descend down in any group, ionization energy decreases because covalent radius increases. And if we consider the ionization energies of 14th group element, as we descend down the group and moving from carbon to silicon, there is a considerable decrease in ionization energy we are going to observe. But silicon onwards, in heavier elements, that much decrease in ionization energy we are not going to observe, and once again it is due to the same effect we are going to call it as poor shielding effect of D and F electrons anta ಹೇಳ್ತೀವಿ. And if we compare the ionization energies, the first IE values of 13th and 14th group elements, ಯಾವುದ್ರದ್ದು ionization energy ಜಾಸ್ತಿ ಇರುತ್ತೆ? As you know, as we move from left to right in any period, their sizes decreases. Size ಕಮ್ಮಿ ಆದ ಹಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಲಿಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. The outermost electron is more tightly bound by the nucleus. So that's why, since 14th group elements are smaller than that of 13th group elements, so that's why due to their smaller sizes, the ionization energies of 14th group elements are smaller than that of 13th group elements, the corresponding element in the 13th group elements. Now let us consider next property, that is the fourth one, electronegativity. Electronegativity. So usually our 14th group elements are more electronegative as compared to 13th group elements. ಯಾಕಂತ ಹೇಳಿದ್ರೆ they are smaller in size as we compare to the corresponding element of 13th group. And once again, as we descend down the group, electronegativity values decreases. So there is a considerable decrease on moving from carbon to silicon, but silicon onwards, their electronegativity values almost remains same. So physical properties of 14th group elements. And if we consider physical properties, all the members of 14th group elements are found to be solids. ಅಲ್ಲಿ ಯಾವುದು liquid ಅಥವಾ gaseous state ಅಲ್ಲಿ ಇಲ್ಲ, all of them are found to be solids. And if we consider carbon and silicon are found to be non-metals. And next, germanium is found to be a metalloid. Metalloid andre nimge gottu, it possesses the properties of both metal and the non-metal, metalloid anta karitivi. And next, tin and lead. ಈ tin ಮತ್ತೆ lead, they are found to be soft metals. Metallic property ಇದೆ, soft metals with the lower melting and boiling point. So tin and lead are found to be soft metal with the lower melting and boiling points. Now, if we consider the melting and boiling points of this 14th group element with that of the 13th group elements, which one is having higher melting and boiling points? So usually 14th group elements are having higher melting and boiling point as compared to 13th. ಯಾಕೆ ಅಂತ ಹೇಳಿದರೆ 14th group elements are smaller than that of the 13th group elements. ಅದರ ಸೈಜ್ ಸಣ್ಣದು, they are found to be more electronegative. ಸೊ ಸೈಜ್ ಸಣ್ಣದಾದ ಹಾಗೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಆದ ಹಾಗೆ ಆಟಮ್ಸ್ ಮೇಡಲ್ಲಿ ವಾಂಡರ್ ವಾಲ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Whenever van der Waals force of attraction becomes stronger, it requires more energy to break this van der Waals force of attraction. That's why they possess higher melting and boiling point as compared to that of the 13th group elements. Now let us move to chemical properties. Third one, chemical properties. So under chemical properties, first we have to study trends, oxidation state and trends in chemical reactivity. So oxidation state and trends in chemical reactivity. Ega, what are the possible, what are the common oxidation state of our 14th group elements? Ega now already nodidvi, general electronic configuration of 14th group element is NS2, NP2. Andre S subshell alli 2 electron ide, P subshell alli 2 electrons ide. So by this losing these 2 electrons present in the P subshell, they will exhibit +2 oxidation state. And sometimes they loses both S and P electron, and also they will exhibit +4 oxidation state. So that's why the common oxidation state exhibited by these 14th group elements is +2 and +4. And next, if we consider the first element carbon, which is found to be most electronegative element among the 14th group, that's why it will exhibit even certain negative oxidation states also. So, carbon exhibit negative oxidation states also. And next, if we consider as we descend down the group, carbon in the silicon, silicon in the germanium, germanium in the tin, tin in the leadic banda hake. The tendency to exhibit +4 oxidation state decreases down the group. Now, ಮೇಲಿಂದ ಕೆಳಗಡೆ ಬಂದ ಹಾಗೆ +4 oxidation stability ಕಮ್ಮಿ ಆಗುತ್ತೆ, +2 oxidation state becomes more stable ಆಗುತ್ತೆ. And this is due to inert pair effect ಅಂತ ಕರಿತೀವಿ. Inert pair effect ಏನು ಹಾಗಂದ್ರೆ, see here, sometimes the electron present in this s orbital, they remain inert and do not participate in chemical bond formation. Then only p electrons will participate in chemical bond formation, and that's why by using only these p electrons they will exhibit +2 oxidation state only. So that's why as we descend down the group, due to the inert pair effect, +2 become more stable and +4 become less stable oxidation state ಆಗುತ್ತೆ. ಇನ್ನು if we consider silicon, if we consider next element silicon, Si, it will exhibit +2 as well as +4 oxidation state, but silicon compounds in +4 oxidation states are more stable. So, +2 is the common oxidation state of silicon agatte. Both carbon and silicon, they will exhibit +4 oxidation state. And if you consider next element, that is germanium. Germanium forms stable compound in +4 oxidation state. Stable compounds in +4 oxidation state, and only a few compounds, in +2 oxidation state. Andre germanium ige once again +4 state is more common oxidation state. Now, if we consider next element, that is tin, Sn. Tin will form compounds in both the oxidation state, +2 as well as +4. ಎರಡು oxidation state ಅಲ್ಲಿ compound formation ಆಗುತ್ತೆ. +2 ಅನ್ನು ನಾವು stannous state ಅಂತ ಕರಿತೀವಿ. ಇದನ್ನು stanic ಅಂತ ಕರಿತೀವಿ. Stannous and stanic. And tin in +2 oxidation state is found to be a good reducing agent. So, tin +2 oxidation state is found to be a good reducing agent. ಯಾಕಂತ ಹೇಳಿದ್ರೆ +2 state ಅಲ್ಲಿ ಇದ್ದಾಗ ಅದು ಈಸಿಯಾಗಿ +4 oxidation stateಗೆ oxidation ಆಗುತ್ತೆ. ಯಾವ ಎಲಿಮೆಂಟ್ by itself undergoes oxidation, that will act as a best reducing agent. So, that's why tin in +2 oxidation state is found to be a good reducing agent. Last element lead bandre. So, Pp. Lead forms stable compounds in +2 oxidation state, and lead compounds in +4 oxidation states are found to be the stronger oxidizing agent. So, lead in +4 oxidation states are found to be stronger oxidizing agent. ಯಾಕಂತ ಹೇಳಿದರೆ they will undergo reduction easily to +2 oxidation state. ಯಾಕಂತ ಹೇಳಿದರೆ +2 is more stable for lead as compared to +4 oxidation state. Now let us consider next properties, that is their reactivity. So under reactivity, now let us consider first reactivity. So under chemical properties we have to consider reactivities. So under reactivities, the first reactivity with the oxygen. Reactivity with oxygen. So our 14th group elements, all 14th group elements, carbon to lead, they react with oxygen and form two types of oxides known as monoxide and dioxides. So monoxides general formula MO and dioxide having the general formula MO2. Monoxide alli metal +2 oxidation state alli idre, dioxide alli +4 oxidation state alli ide. Innu if we consider monoxide, so carbon is monoxide andre carbon monoxide. Innu next silicon is monoxide andre SiO, germanium monoxide GeO, then SNO and PbO. These are the monoxide formed by 14th group elements. And next if you consider dioxide, carbon dioxide, silicon dioxide, germanium dioxide and tin dioxide and lead dioxide PbO2. And carbon monoxide is found to be neutral in nature. ಅದರ ಪ್ರಾಪರ್ಟಿಗೆ ಬಂದರೆ ಅದು ಅಸಿಡಿಕ್ಕು ಅಲ್ಲ, ಬೇಸಿಕ್ಕು ಅಲ್ಲ, ಇಟ್ ಈಸ್ ಫೌಂಡ್ ಟು ಬಿ ಎ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸೈಡ್. ದೆನ್ ರಿಮೈನಿಂಗ್ ಆಕ್ಸೈಡ್ಸ್ GeO, that is silicon oxide SiO, it is found to be stable only at high temperature. So the room temperature alli monoxide of silicon is not found to exist. And remaining oxide GeO2, PbO, they are found to be amphoteric in nature. Amphoteric andre ಗೊತ್ತು ಮಕ್ಕಳೇ ನಿಮಗೆ, ಅದು it is having the properties of both acid as well as base. So those compound which are having properties of both acid as well as bases, we are going to call them as amphoteric substances ಅಂತ ಕರಿತೀವಿ. If we move to dioxide, so carbon monoxide, SiO2 and GeO2, these three dioxides are found to be acidic, and remaining two dioxide, they are found to be amphoteric. One of the possible question for an examination, name the oxide which is formed by 14th group element which is having the highest acidic nature. The most acidic oxide formed by 14th group elements yaudu anta kelidre, it is nothing but carbon dioxide. So among this one, carbon dioxide is found to be highly acidic in nature. ಇನ್ನು ಒಂದು ಎಲಿಮೆಂಟ್ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಕ್ಸೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ಬೋದು. ಈಗ ಕಾರ್ಬನ್ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್. ಈಗ ಎರಡು ಆಕ್ಸೈಡ್, ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಕ್ಸೈಡ್ ಇದ್ದರೆ ವಿಚ್ ಈಸ್ ಮೋಸ್ಟ್ ಅಸಿಡಿಕ್ ಆಕ್ಸೈಡ್ ಅಂತ ಕೆಲವು ಸಲ ಕ್ವಶನ್ ಬರುತ್ತೆ. ಸೊ ಇನ್ ಆರ್ಡರ್ ಟು ಫೈಂಡ್ ವಿಚ್ ಈಸ್ ಮೋಸ್ಟ್ ಅಸಿಡಿಕ್, ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್. ಇನ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್, carbon is in +2 oxidation state. In carbon dioxide, carbon is in +4 oxidation state. So ಹಾಗೆ highest oxidation state ಅಲ್ಲಿರುವಂಥದ್ದು carbon dioxide ಅಲ್ಲಿ. That's why carbon dioxide is most acidic than carbon monoxide. So this is about their reactivity with oxygen. Now, let us consider reactivity with water. So next, number 2, reactivity with water. So if we consider 14th group elements, the first 2 elements, that is carbon, silicon as well as germanium, all the 3 elements, they are not affected by water. They do not react with water under normal temperature or at higher temperature. But if we consider tin, so tin, it won't react with water at room temperature, but it will react with steam, ugi anta karitivi. So steam ಒಟ್ಟಿಗೆ tin reaction ಆಗತ್ತೆ, and it will form tin oxide SnO2 with the liberation of hydrogen gas. So that's why idu steam andre ನಾವು heat ಮಾಡಬೇಕು, ಆಗ tin water ಒಟ್ಟಿಗೆ reaction ಆಗಿ tin dioxide ಮತ್ತೆ hydrogen gas ಬರುತ್ತೆ. And in order to balance this equation, here 2 oxygen atom, that's why you have to write it here 2. Then hydrogen becomes 4. In order to balance the hydrogen, it should be 2. So this is the reaction of tin with the steam. And the last element, lead, Pb, it is usually unaffected by water ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ lead ಒಂದ್ಸಲ ವಾಟರ್ ಒಟ್ಟಿಗೆ ರಿಯಾಕ್ಷನ್ ಆಗಿ lead oxide ಫಾರ್ಮೇಷನ್ ಆಗತ್ತೆ. ಈ lead oxide ಬಂದದ್ದು ಆ lead metal ಸುತ್ತಲೂ ಒಂದು ಲೇಯರ್ ಆಗಿ ಉಳಿದ್ಬಿಡತ್ತೆ. And it will prevent the further reaction of the metal with water. So lead adrinda further water ಒಟ್ಟಿಗೆ reaction ಆಗಲ್ಲ. That's why lead is unaffected by water ಅಂತ ಹೇಳ್ತೀವಿ. So after reactivity with water, next we have to study reactivity with halogens. So next, reactivity with halogen. Halogens. So all group 14th element, they react with halogen and forms 2 types of halides with general formula MX2 dihalides anta karitive, innu MX4 tetrahalides anta karitive. And here X is either fluorine or chlorine or bromine or iodine. So 14th group elements form 2 types of halide, MX2 and MX4 are the general formulas of these 2 halides. Now if we consider first element, that is carbon, it won't react directly with halogens. It won't form halides directly. And except carbon, remaining all elements, silicon, germanium, tin and lead, all the 4 elements, they will react directly with halogen and forms halides. And next, if we consider next point, tetrahalides. So if we consider any tetrahalide, they are found to be covalent in nature. ಎಲ್ಲ tetrahalide covalent in nature. And in all tetrahalide, the central element undergo sp3 hybridization. Central element sp3 hybridization ಆಗುತ್ತೆ. ನಿಮ್ಗೆ ಗೊತ್ತು, whenever an element undergo sp3 hybridization, always its geometry is tetrahedral. ಹಾಗಾಗಿ ಎಲ್ಲ tetrahalides ದ geometry tetrahedral ಇದೆ. ಇನ್ನು there are two exceptions. Tin tetrafluoride SnF4 ಮತ್ತು PbF4. ಇಲ್ಲಿ ಫ್ಲೋರಿನ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಎಲಿಮೆಂಟ್ ಇನ್ ದ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್. ಅದರ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಹೈಯೆಸ್ಟ್ ಇರೋದ್ರಿಂದ ಅದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಈ ಮೆಟಲಿಂದ ಎಳ್ಕೊಳ್ಳುತ್ತೆ, ಪಡೀತದೆ. ಆ್ಯಂಡ್ ದಟ್ಸ್ ವೈ ದೀಸ್ ಟು ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಫೌಂಡ್ ಟು ಬಿ ಅಯಾನಿಕ್ ಇನ್ ನೇಚರ್. ಇದೆರಡು ಕಾಂಪೌಂಡ್ಸ್ ಬಿಟ್ಟರೆ ಉಳಿದ ಎಲ್ಲ ಟೆಟ್ರಾಹ್ಯಾಲೈಡ್ಸ್ ದೇ ಆರ್ ಫೌಂಡ್ ಟು ಬಿ ಕೋವೆಲೆಂಟ್ ಇನ್ ನೇಚರ್ ಆ್ಯಂಡ್ ಹ್ಯಾವ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಶೇಪ್. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್, ಇಫ್ ಯು ಕನ್ಸಿಡರ್ PbI4, lead tetraiodide, it do not exist. ಇದು ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. lead can't form 4 covalent bonds with iodine. ಯಾಕಂತ ಹೇಳಿದರೆ, if we consider lead in its valency shell, leadನ ವೇಲೆನ್ಸಿ ಶೆಲ್ಲಲ್ಲಿ ನಿಮ್ಗೆ ಗೊತ್ತು 6s ಆರ್ಬಿಟಲಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಮತ್ತು p ಆರ್ಬಿಟಲಲ್ಲಿ 6p ಆರ್ಬಿಟಲ್ಸಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. In order to form 4 covalent bond, there should be 4 orbitals with unpaired electrons. ಹಾಗಾಗಿ ಒಂದು ಇಲ್ಲಿರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿಗೆ ಎಕ್ಸೈಟೇಷನ್ ಆಗಬೇಕು. ಆಗ ಮಾತ್ರ 4 ಆರ್ಬಿಟಲ್ಸ್ ವಿತ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ನಮ್ಗೆ ಸಿಗತ್ತೆ. ಆದರೆ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಕ್ಸೈಟೇಷನ್ ಆಗಬೇಕು ಅಂದರೆ ಎನರ್ಜಿ ಬೇಕು. ಆದರೆ ಇಲ್ಲಿ ಲೆಡ್ಡಲ್ಲಿ ಫಸ್ಟ್ ಒಂದು PbI ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆದಾಗ ರಿಲೀಸ್ ಆದ ಎನರ್ಜಿ ಇದೆ ಅಲ್ವಾ, ಅದು ತುಂಬ ಕಮ್ಮಿ. ಆ್ಯಂಡ್ ದಿಸ್ ರಿಲೀಸ್ಡ್ ಎನರ್ಜಿ is not sufficient to promote the s electron to the vacant p orbital. ಹಾಗಾಗಿ s electron excitation ಆಗಲ್ಲ, 4 ಆರ್ಬಿಟಲ್ ವಿತ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಸಿಗಲ್ಲ. and that's the reason why PbI4 do not exist. And now if we consider, if we move down the group, stabilities of dihalide increases. So X2 are found to be more stable as compared to X4. So dihalide stability increases as we descend down the group. And next, all tetrachloride except carbon, all tetrachlorides except carbon, all tetrachlorides undergo hydrolysis with water. ಅದು ವಾಟರ್ ಒಟ್ಟಿಗೆ ರಿಯಾಕ್ಷನ್ ಆಗತ್ತೆ. ಯಾಕಂತ ಹೇಳಿದರೆ, ಎಕ್ಸೆಪ್ಟ್ ಕಾರ್ಬನ್, ರಿಮೈನಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ 14th group, ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ empty d ಆರ್ಬಿಟಲ್. ಆಗ್ತಾನೆ ನಾವು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರೆದ್ವಿ, ಅಲ್ಲಿ ನೋಡಿದ್ವಿ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸಲ್ಲಿ ಅದರ ವೇಲೆನ್ಸಿ ಶೆಲ್ಲಲ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಬರುತ್ತೆ. ಆ್ಯಂಡ್ ದೀಸ್ ಎಂಟಿ ಡಿ ಆರ್ಬಿಟಲ್ ಕ್ಯಾನ್ ಅಕೊಮಡೇಟ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಡೊನೇಟೆಡ್ ಬೈ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್. ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತು, water is the structure nodidira ನೀವು chemical bonding alli. There are 2 lone pairs of electrons are there over oxygen atom. Due to the presence of this lone pair of electron, water molecule act as electron pair donor. ಈ oxygen ಕೊಟ್ಟಂತ electron ನಮ್ಮ 14th ಗ್ರೂಪಿನ ಉಳಿದ ಎಲಿಮೆಂಟ್ಸ್ ಕಾರ್ಬನ್ ಬಿಟ್ಟು ಉಳಿದ ಎಲಿಮೆಂಟ್ಸ್ they will accommodate in their empty d orbital and hence they will undergo hydrolysis with water. ಆದರೆ ಕಾರ್ಬನಿನ ವೇಲೆನ್ಸಿ ಶೆಲ್ಲಲ್ಲಿ 2s ಮತ್ತು 2p ಆರ್ಬಿಟಲ್ಸ್ ಮಾತ್ರ ಬರುತ್ತೆ. ಸೆಕೆಂಡ್ ಶೆಲ್ಲಲ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ ಇಲ್ಲ, ಕಾರ್ಬನಲ್ಲಿ ಎಂಟಿ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಇಲ್ಲ, and that's why it can't accept the electron from water molecule, and that's why it do not undergo hydrolysis. Now hydrolysis of tetrachloride can be easily understood by taking the example of SiCl4. So silicon tetrachloride ಅನ್ನು ನಾವು ತಗೊಂಡ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತು ಎಲ್ಲ ಟೆಟ್ರಾ ಹ್ಯಾಲೈಡ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಶೇಪ್ ಅಂತ ಈಗ ತಾನೇ ನೋಡಿದ್ವಿ. So whenever it reacts with water, this is water and this water is having 2 lone pairs of electrons and silicon is having empty d orbital in its valency shell 3d orbitals ide. ಹಾಗಾಗಿ water molecule will donate the electron to silicon and chlorine is removed here. So that's why ಇಲ್ಲಿದು H ಮತ್ತು ಇಲ್ಲಿದು Cl, HCl ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಒಂದು ಕ್ಲೋರಿನ್ ಇದ್ದಲ್ಲಿ OH ಬಂದು ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ Cl 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 ಈ Cl ಇದ್ದಲ್ಲಿ ಈಗ OH ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗುತ್ತೆ. ಇದು H ಮತ್ತು ಇದು Cl, HCl ಹೋಯಿತು. This OH group is substituted here. Similarly, there are 3 more chlorine atoms. Still it is having empty d orbital. That's why it further reacts with 3 more molecules of water molecules. ಹಾಗಾಗಿ 3 ಇಲ್ಲಿ ಆದ ಹಾಗೆ 3 ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒಟ್ಟಿಗೆ ರಿಯಾಕ್ಷನ್ ಆದಾಗ 3 HCl ರಿಮೂವಲ್ ಆಗುತ್ತೆ. and finally we going to get Si, here OH, here OH, here OH and here OH. So all the 4 chlorine atoms are now substituted by OH group and it is known as silicic acid. Silicic acid anta kariತೀವಿ, silicic acid. So this is about the hydrolysis of silicon tetrachloride. So here we have finished the chemical reactivity with water. So okay dear students, so in today's class we have studied about which are the members belongs to 14th group, what are their general properties, their occurrence, their physical properties, their oxidation states and also their reactivity with oxygen, water and halogens. So in next class we are going to study certain anomalous behavior, anomalous properties of carbon and about the 3 important isotopes of carbon, that is diamond, graphite and fullerenes.